Hello, CIT130 class. This week we're going to talk about the introduction to inheritance. So we'll kind of go through the subject. Like I said, remember this is just a lecture. This is not a lot of the on-site looking at lab work. So we're going to learn about the concept of inheritance, extend classes, override superclass methods, call constructors during an inheritance, access superclass methods, employ information hiding, and learn which methods you can override. So inheritance, what is it? It's a mechanism that enables one class to inherit both behavior and attributes of another class. Apply your knowledge to a general category to more specific objects. So normally if I have an open class, I like to bring this up in discussion. What is inheritance? Think about things that you can inherit. So for example, let's say that you're a parent. So that could be mom or dad. And they have a child. We'll say children. We'll say child 1. We'll say child 2. Well, normally each child inherits something different. So let's say child 1 inherits mom's nose, eyes, but child number 2 inherits mom's overall look, appearance, and maybe dad's smile. These are all examples of inherit because these are things that you can inherit from your parents, also known as traits. So let's say that you have child number 1. Okay, child number 1 is 6'8". Where did he get that at? He got that from his dad. His dad is tall. That's something that he inherited from him. Let's say in addition is he has bowling. Where did he get that at? Potentially his dad. But science really says it's your mother's father you've inherited it from. So let's say we go by science and he inherited it from his grandfather, which happens to be his mom's dad. Science, that's what they say. Anyhow, so you got bowling. Then you might have something else. You might have walk. Maybe inherit it from his mom. These are just examples of inheritance. So when we're actually talking about objects and classes, let's say that we have a class called, we could say class is called vehicle. Okay. We'll say maybe more specific. Vehicle is just not specific enough. Let's say tires. Okay, so we know we have a class in tires. We also have this class called, let me think of something, radio. All right, so what are these classes made up? So tires, we're going to build a class. Let's put in here. We are going to build a class called tires. In this class is going to be all of the different tires. So there's a lot of different tires. So we'll name a couple. There's Cooper. There is Michelin, which I'm probably spelling wrong. Yeah, they do not agree with me. Michelin is a very popular one. I guess that's how you spell it. I don't know. Anyways, there's Goodyear. There is Firestone. Just trying to think some off the top of my head. There's a very popular one called Yokoshumi, something like that, Yokohama. I forget, it's a very popular one. All right, so we'll just say that we have 5 of these different tires. And these are just right here, these are brands. So we'll have a class, and in our subclass, we'll have, let's just put it down there. So you have main class is tires. Subclass is types, we'll say brand of tires. So these are just brands. So then we're going to need another subclass. We're going to need a subclass called, we already have branded tires, so now we need the size of tires, right? So size of tires. So we're going to need to represent the size of tires. And you know what? In our lab, we'll actually create this model as code. But right now, I just want you guys to kind of get examples or thinking about this. So size of tires, you might have 260 by, I'm trying to remember what they are, 15 by 65, something like that. And then you would have all tire sizes here. Then that's another subclass. Then let's see, what else can you have besides in tires? You have your type of tire, you have your brand of tire. What else can exist in a tire? And there may be things that you guys are thinking of, and you could say, hey, you know what, Jeff, we could add this or that. These are just things I'm thinking off the top of my head. So let's just end there. So let's go to the next one, which is main class is radio. All right, so then subclass can be what type of radio. Subclass could be types of radios. And you might have external. You might, I'm just throwing stupid stuff out there. Internal with CD player. Internal with CD player and MP capabilities. You get my gist. And then you might have another subclass that talks about, might be features. Okay, what features do you have? You might have features for XM/Sirius radio. You might have navigation built in. You might have, believe it or not, Facebook. I have Facebook app built into my vehicle. I think it's, if you're going places you want to check in. Now, it doesn't allow you to do it while you're driving. It's only when you're stationary, but I'm not sure what the whole idea of it is. Anyhow, iHeartRadio. So it connects to your phone and uses iHeartRadio. Let's see here. There's what is it? Fuel and something else. We'll just put fuel. So those are different features that you can have. All right. So we have figured out that we have three classes, right? We have type of radio. We'll just put radio, tires. We need another class, which is our main class. We'll just call it main class. So what we're going to do in our main class is we are going to use something called a constructor to obtain the data from radio and tire classes. And like I said, we'll go through this in the lab, but start thinking about, read through the chapter and figure out how you could do that, and we'll talk about it more. But that's an example of inheritance. All right, so we'll skip that. All right, so we'll skip this because we basically just did that in a sense. But this is an employee diagram. You have an employee. Excuse me. You have an employee, ID and salary, and then you have these features down here: get ID, get salary, set ID, set salary. And that's things that we'll talk about is, getting back to the, where's it at? Getting back to, that's the wrong one. Okay, getting back to this right here, we're going to have to set gets and sets. So we're going to have to set values. So we'll set features are blah, 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 blah. And then we'll do get features, get radio, and so forth. And those will be ways that you could call your values. Diagram inheritance using the UML continued. This right here All right, so we have the diagram of inheritance using the UML. So it has employee and it has employee with territory. So employee is the primary one, but here's another one. Class diagram shows relationship between employees and employee with territory. So it allows you to have employee, but also has another class that talks about specific territories. So in inheritance, to create a derived class, you'll have different classes. One's a derived. You save time, you reduce errors, and reduce the amount of new learning required to use a new class. Because what's happening is, the nice feature is you're only utilizing, so save time and reduce errors. And the thing is, when you set up these different classes, not everybody does this. This is when you're learning to program and use inheritance. Down the road, when you're setting up a, let's actually show you something real quick. Let me pull up a doc here. We don't want that one. Let's just do this one, the new one. So you're learning about inheritance right now, which, it's new and it may not make the most sense. But when you set up a perfect environment, and I say perfect environment, best practice environment, basically, you'll have, let's say that you're setting up a web environment. Okay, you might have one called infrastructure. So you'll have a project. I can't even spell infrastructure. So this will be a project within Java. And then under there, you'll have all your infrastructure information. So then you might have interface. And this is another project. Now, what's interesting about the interface, you'll have inheritance that resides under that project as a subtask. Okay, and then you might have something called core. It's actually at the top. So it should be at the top up here. And these are your core tasks. And then this is just an example here. Then you would have something called DTO, which is another project, and it's for just transformation links. And we're not learning about that in this class, but just kind of give an example. And then you would have, like, say, your web environment or a swing form component. See, what actually happens is the interface part of it is the medium between the swing form and other elements. So basically what that means is you're using a type of class object that is relies on each other. So it's a dependency class, basically. You can't do one part and not do the other part. They all have to live together, but it also protects your infrastructure. So you're not able to just easily willy-nilly throw something out there and it goes out there. It has to meet all the odds. It's a little more complicated, and we will not get into those discussions, but just to kind of throw that out there, think about that. When you're setting up a project, you want to make sure that whether it's Java, .NET, whatever the case is, you want to make sure it has multiple projects and they're able to interface properly. But anyways, I just want to kind of throw that out there. That's why this right here helps out. All right, base class used as a base for inheritance, also called the superclass or parent class. We talked a little bit about the parent and the child, so that would be an example of that. Derived class, it inherits from a base class. It also is a case or an example of a more base class, also called a subclass or a child class. So we talked about the subclass and the child class. That would be an example of when we talked about, I don't have it here, I don't know what the heck happened to it, but anyways, not that one, it'll pop up, there we go. These would be example, I have to keep it to the side here. These will be example of your subclass or your child class, your features, your types of radio, your brand of tires, and so forth. So that would be an example of that. Keyword extends, used to achieve inheritance in Java. So example here is we have public class employee with territory extends employee. So what we could do here in our little example that we talked about is we could say public class, and we could say vehicle, because it describes the type of vehicle, and we could say extends what? We can extend anything that we talked about over here. It has to be a main class now. It can't be the subclass. So our main class is tires and radio. So we'll just say extends radio. All right. So what that means here is we're saying that this vehicle class extends radio. Let me actually get some room here so that we could do something. In a nutshell, in our code here, we could say, oh, okay, extends radio. So what do we want to do? We could create a constructor, and in a constructor, it might be radio. We could do radio dot. We could do a get function here. So we could get a function and get the value from radio right in this class. So we might get say the type of radio, and we could list the different radios here. We could use an array or whatever the case is. But this is just an example of what we were talking about. Oops. Inheritance is a one-way proposition. It's a child that inherits from the parent, not the other way around. So this right here is the parent, and the radio or brand or whatever is the child. So just remember that. Let me extend this here. Subclasses are more specific instance of an operator. All right, so extending a class here within this employee thing, it says extends employee. They declare a private integer called territory. They say the private integer get territory, return territory. So it returns the territory, which is its value here. Then it says set territory. So we're doing a get and set. You set it to whatever the value is, and territory equals ter, so whatever that value was set. Now it's getting this information from that employee class that has the territory and has the ability to set it. And like I said, we'll get more into detail when we get into the lab part of that. So create a subclass by extending an existing class. A subclass contains data and methods defined in the original superclass. So remember that the subclass contains data and methods defined in the original superclass. And sometimes superclass data fields and methods are not entirely appropriate for the subclass objects. What does that mean? Well, it just means that sometimes there's features or functionalities that is not able to be utilized. Keyword, polymorphism. Remember this keyword. You may see it on an exam. It is the same method name that is used to indicate different implementations. So it basically could take control of other functionality. It could take on other classes. It could do a lot of other things. So just remember that it is used to indicate different implementations. I would read about it in your book. Override the method. So you may have heard of override the method in CIT111. I'm not sure. But this is a key feature that if you learn in this class, you could go and learn Android development, which is CIT135 class, and it we'll talk about a lot of overrides. Create a method in a child class that has the same name and parameter list as a method in its parent class. Normally you can't do that because it's going to say, you know what, that already exists, but you can override it and say, you know what, I'm giving you permission to do that. So go ahead and do it. Subtype polymorphism. It's the ability of a method named to work appropriately for different subclasses, objects of the same parent class. Goes back to polymorphism. It's able to take on other, just think of it being able to take on other tasks. Be like if you had a job and you work at a convenience store and your job is to make subs. That's it. You just make subs, that's it. You don't work the cash register. You don't, excuse me, you don't stock the back, the soda, the milk. You don't take orders. But let's pretend that you are a subtype of polymorphism. Not only in that feature, you could do anything. You could take orders, you could act as a manager, you could work as cash register, you could help people at the pump, you could do all these different features. So just think that as an example of someone with that ability. Override annotation, override. So this is when we're talking about the override the method, this is the annotation that you would write above your code. It tells the compiler that you're overriding a parent class. So you can easily comment it out when you're doing it, You comment it out, or you could leave it go. And we'll show some examples in the lab. So when you instantiate an object that is a member of a subclass, you call at least two constructors. Now, there's a constructor for the base class, and then you have the extended class. A superclass constructor has to be executed first, or it won't work. Because the superclass contains the default constructor. The execution of this superclass constructor is the transparent. So remember those keywords. So calling constructors during inheritance. So continue. You have your public class, a superclass. Public a superclass, it's writing out and saying I'm a superclass constructor. Let's say that public class a subclass extends a superclass. Public a superclass. So it has these different subclasses here, and you could call the different subclasses within your code. So it just shows you how to do constructor calling subclass when the object is instantiated. I'd like to see if there's any questions, but you can't answer that. All right. So it ran that right there. It's a demo constructor and superclass constructor and subclass. And we'll go over that in our lab. When you write your own constructor, you replace the automatically supplied version. When extending a superclass with constructors that require arguments, the subclass must provide the superclass constructor with the argument that it needs. When a superclass has a default constructor, you create a subclass with or without its own constructor. When a superclass contains only constructors that require arguments, you must include at least one constructor for each subclass you create. The first statement within each constructor must call one of the superclass methods. Calling superclass constructor, super, and then whatever the list of arguments are. Let's see here, we talked about that. So here's an example of a superclass. So you have your class extending customer, so it's getting the customer information. You're declaring a data type of a double discount rate. You're saying that the public preferred customer, you're giving it arguments that accepts the integer for ID, a double balance, a double rate. So now you're going to call that superclass, and you're going to pass ID and balance to it. A discount rate, which we already declared up here, equals the rate, whatever the rate is provided within here. Now what we're doing down here, we're saying, hey, let's put an override in. We're overriding, creating a display, and say super.display, which is in the superclass, and the discount rate is discount rate. So we'll try this in our lesson, is if we actually take the override out and just run this and see what happens. Kind of seeing the lab work, what happens in the difference. It's kind of hard to explain right now, but just kind of think about it. If you want to take a chance before you get to the lab and do it yourself, I say do it. Try it out, see what happens. Think of the keyword this as the opposite of a super within a subclass. When a parent class contains a method that is not overridden, the child can use the method with the super or this alone. So when a parent class contains a method that is not overridden, the child can use it, but if it's overridden, we can't use it. So think of it as, all right, your parent grounds you. You can't go to an event that you want to go to after school. It's the football game. Your parent says, you know what, Sally had bad grades this semester or this quarter, and basically is overridden. That would be an example. But if your parent didn't override it and say, hey, you know what, well, you're not grounded, guess what? You can use it. So think of it that way. Within the student class, the keyword private precedes each data element, each data field per se. The keyword public precedes each method. Information hiding, the concept of keeping data private. Data can be altered by methods you choose and only in which way they can be controlled. All right, so here is an example. We have our class student. So we have public class student, back to it. We're declaring some variable types here. And we have some gets. As you see here, all these gets and sets. So you can't have a get without a set. Set happens first and get comes in return. So, you know, you're setting the ID Like in this case, you're getting the ID num, which is declared up here, but you have to set it first. ID num equals num, because what you do is you call this guy right here and pass in a value. And let's say that we pass in 5. We say that ID num equals 5. And then when we get that return, we actually get it, we call that and it returns that value. But it can't return it until you set it. So think of that. And when we look at the lab, you'll be able to see what I mean. When a class serves as a superclass, subclasses inherit all data and methods of a superclass, except private members of the parent class are not accessible within a child's method. Keyword protected. So what is protected? You may have learned about it in CIT130. I hope that you have. Provides an intermediate level of security between public and private access. Can be used within its own class or in any class extended from the class. Cannot be used outside classes. So this is kind of an example is can be used within its own class or in any class extended from a class. So let's go back to the parent rule. Okay, you have mom, dad, child. Let's say that you have a cousin. Okay, you could allow your cousin to use, let's say that you have, well, I'm trying to think of something. Swimming pool. All right, mom and dad allows you to go swimming, but if they want to, they could extend the invitation out to your cousins or your friends. But if you're not using the extended class, guess what? Your cousins and friends can't come over swimming. So basically what that means is if you're not using the extended keyword, it's not going to happen. You're not going to be able to use it if it's public or private. We have static methods and final methods. Methods with final classes. A subclass cannot override a method declared static in a superclass. A subclass can hide a static method in a superclass by declaring a static method within the same signature as a static method in the superclass. Sounds really confusing. It sounds like a mouthful, so I get that. So just think about it. You have a subclass. They can hide a static method. A static method is something that doesn't change. In the superclass, by declaring the static method within the same signature as a static method in the superclass. So it's basically an override. You're given the ability to do something different. Let's see here. All right, here's an example. Public class professional baseball player extends baseball player. Baseball player dot. As you see here, we do the dot show origins. Sorry, can't even type. Can't even talk. So by doing that, it allows it to print the information. So this is an example here. You take the baseball player, extends it, dot, show origins. It might be other features in there when you type the dot as well. Subclass cannot override methods declared final in a superclass. Why is that? Well, because when it's final, it's done. It's the final modifier. You can't touch that. Does not allow the method to be overridden. Virtual methods calls default in Java. The method uses to determine which program runs, and so forth. A subclass can not override. Okay. Advantages to making a method final. The compiler knows that only one version of a method exists. So that would be Eclipse IDE. It also knows that the method version will be used. A program's performance can be optimized by removing calls to the final method. So you can not make calls to the final method and it would be fine. When a class is declared final, all its methods are final regardless of which access modifier precedes the final name. It cannot be the parent class. So just think of this. All right, and now I keep going back to this, but it's a good example. So your parent, we're all children at one time. Your parent says, nope, you're not going to the baseball game. No matter what you do, I'm sorry, but this is it. That would be a final ruling. It can't be changed because they said so. Well, let's say that grandma comes over and says, you know what? I'm taking Sally to the baseball game regardless because I'm her grandmother. It doesn't work that way. The parent made the rule. It's set in stone, and that's just the way it works. So that would be an example of what I'm talking about. Hopefully that makes sense. So this right here, I'll let you look at it. It shows you, notice the keyword final in the method. It says don't do it. You can extend a final class. So basically, what did we do? We demonstrated the inheritance. We talked about overriding. We talked about the role of constructors. We talked about the instance of an operator, the final method. Summary, polymorphism, keyword extends, inheritance, superclass, protected and public and private, some static variables, and so forth. So in the lab work, we'll go through all this stuff. We'll create our little thing with tires and so forth. We'll show you how it works, and it will make a lot more sense, I hope. So if you have any questions, once again, I appreciate you listening to my tutorial. I'd say go back to the tutorials, screenshots, whatever you need to do to understand this. But email me, contact me if you have questions on specific. And there's also a discussion forum out there for assignment questions or any questions at all. General questions that you're unsure of. Reach out to me. Thanks and have a good week.